Hello students, welcome back. Now let's go to section 4 of this practice exam problem set, L'Hopital's rule. Here are two typical L'Hopital's rule computation problems, but written in a little bit confusing fashion intentionally. First problem is pretty much straightforward. Horizontal asymptote is limited infinity, so you should see that, find out the horizontal asymptote. That means limit as x going to infinity f of x. So basically you're looking for limited infinity of this 0 times infinity type limit. If you have 0 times infinity type limit, what do you do? Make it into fraction and apply L'Hopital's rule. And that's basically what this is all about. Make it a fraction and then take the L'Hopital's rule. Take the derivative, simplify. I still have x there, so do it again. Take the derivative once again. Now, completely gone in the numerator, so denominator is still, we have something humongous, so 3 over infinity, yeah, that's 0. So two applications of L'Hopital's rule, and that was actually easy computation. But to see that this is a L'Hopital's rule problem, actually the problem actually said use L'Hopital's rule, so okay, L'Hopital's rule, right? But seeing that horizontal asymptote is limited infinity, it's not that simple, but still, this is standard. Thinking about limited infinity from horizontal asymptote, that's something you should be able to do. Now, I cannot say the same for the second problem here. Prove that piecewise defined function f of x is continuous. What do you mean by that? Well, continuous means limit toward that is the function value. Function value is 0, so limit at 0 will turn out to be 0. That's what you have to prove. And that's something you saw way back in, let's see, week 2. Yeah, I think you saw it week 2, maybe in week 3 when we did continuity. We did limited continuity there, and then we never came back. As for horizontal asymptote business, we talked about it in week 2 and week 3, yes, but periodically we came back and discussed those. We didn't do that for here, so this problem would have been a little bit exceptional if this problem set had been real exam problem set. But here, come on, this is just practice exam problem set, so I felt rather free to give you different aspects of the same problem. So I did it like this. So here's a piecewise defined function, and then prove continuity, which means calculate the limit and verify that the answer turns out to be 0. So okay, all right. Is it really turning out to be 0? Well, if you have 0 times the infinity type limit, most of the time it will turn out to be 0, and exceptional cases, of course, do occur, but most of them will be discussed in calculus 2, not here. So you can safely say you can get 0, but let's check. We have x times logarithm, so we have to change this into a fraction. Now, if you put log into the denominator, you'll see. Try to take the try to take the derivative of that log to the negative first power, and you'll see it's way too complicated. And the purpose of L'Hopital's rule is to obtain the limit simpler than before, but that's clearly counterproductive. Now, if you put logarithm up here and put the power function into denominator, taking negative power, then it comes nicely. It is possible to take the limit easily. As a matter of fact, here, let me expand the font. Here, I use chain rule to calculate 1 over whatever inside and then the derivative, but would have been a little bit easier if you used the log rule to simplify this. And then, of course, you have to consider x is going positive or negative. That issue is there. So this going to 0 plus and that going to 0 minus. You have to consider them separately. But if you did that, then eventually you're going to get the same result as before. You're going to get 2 over x or equivalently speaking, 2x to the negative first power in the numerator. So after simplification, you're going to get negative 2x there. On second thought, this isn't really that easy. I mean, this is for positive, and then same goes for if x is negative, and you have to work those out. But maybe this was not really a good idea. Let's go back to the original idea. Take the log of this x squared. So take chain rule, 1 over x squared, whatever inside of the log goes to denominator, and by chain rule, derivative of the numerator, derivative of the inside, and derivative inside becomes a numerator. After simplification, we get that, and then now plug in 0. It'll work out. Anyway, the limit computation was a little bit tougher than previously, but also the way it was written is a bit deeper as well. Here, horizontal asymptote going to limited infinity. That should be clear to everybody. As for continuity becoming limit at whatever this value, okay, here's a reminder. We did it a long time ago, but it's a good time to come back and revisit it. In any case, we completed the limit computation problems through L'Hopital's rule. Okay, thank you. Everybody have good luck.